Okay, 4-8. We are almost to the end of this unit. We end at, I believe, 4-9, so we're getting very close. We're going to talk about acid and base reactions today then. Acid-base reaction, we talked about this a little bit yesterday in yesterday's notes, and we touched on it briefly when we first began the unit as well. Acid-base reaction, you're going to have the proton of hydrogen is getting transferred from one species to another. Remember that the acid is going to be donating that hydrogen and the base is going to be accepting it. It's important not only to identify it if it's a reaction that whether it's acid and base, but also to be able to identify which ones are the acids and the bases in that reaction. We define those here in this chemistry class as the substance that donates a proton, and if that makes it an acid, and if it accepts that proton, then it's the base. There are other definitions of bases and acids. I believe the other one that they use a lot in college is Lewis acids and bases. That gets a little bit more complex yet. So if you get into more advanced chemistry, you might fall into that category and have to identify them. This is much easier, so you can be thankful for that. Okay. When an acid or transfers a proton to a base, the acid becomes the conjugate base. The acid and the conjugate base then make up that acid-base pair. And I told you guys to kind of find the two things that look similar to each other. And then from there, you can figure out which one has more hydrogen. That's your acid. The other one's going to be your base. So the conjugate acid-base pair will always differ by only one proton. Water is a unique species because it can act as an acid or a base, and we call that amphoteric. Good. Okay. So here are some examples of that. Again, we talked about that yesterday, but this is just a generalized form. HA is your acid. We put an H in front of it, and then this is going to be some sort of anion. So this will be some sort of negative charge here. Your hydrogen will be a positive, and they'll balance each other out. Then you're going to add water. That H is going to get donated to the water, so that becomes your conjugate acid. And then over here, this will then be your conjugate base. So this will be OH minus in this case. No, that's not right. That's not right. This will be your anion, whatever anion that was over here is the anion here with the negative charge. Okay, now I'm hopefully done being stupid. Base then here in the presence of acid, that's going to leave the OH behind, and then your conjugate acid is going to pick up that base from over here. Okay, they can vary in strength. So depending on, and we talked about strength yesterday, and I told you that when we get into Unit 8, you'll actually be able to figure out based on numbers, numerically, without them telling you, you'll be able to understand how to do those acid-base pairs and which one's more strong based on the values that you are given. Okay. So, acids and bases can vary in strength. A strong acid or base will ionize completely in water, and we use just a forward arrow to indicate that. A weak acid or a base does not ionize completely. Not all of this breaks apart and forms these two things. Weak acids, though, they end up favoring, or you end up having more reactant than you have product. So you've got a little bit of it that's this side and a little bit of it this side. Now, in actuality, what's happening is some of this is forming into this, and then some of this is actually reforming back into this. And it's this back and forth. But very little of this is going to this side. And so you don't have as much over here as you would have over here. So if this was like a seesaw, right, your heavier person or the more amount would be on this side over here. You'd have a seesaw that would be like this because you got more stuff over here than over here. In this case, it's going to favor this side, and you're going to have more stuff on this side than you would have over here. So very little over here. Most of it's going to be on this side, if not all. Okay, does that make sense? My seesaw analogy? You guys got to play on seesaws, or were they outlawed by the time you got to be kids and because they were too dangerous? Yeah. They got to wrap you guys in bubble wrap, you know. Yeah, no. Seesaw, you would they just had like a pivot point here and one person would yeah. That, okay. So how her question was how can you look at this and tell if the acid is weak or strong? First of all, you will get to the point, and it is today, where you're going to memorize a list of strong acids and bases. So that is clue number one. Clue number two, and even easier than that, is you look at these arrows. If the arrow is pointing in one direction, and that is to the product side, this is a strong acid. If the arrow is pointing in both directions, and typically when we write this, we write it like this without that being so wavy in the middle. We write it as a front and back arrow. If you see that, then that means that it's going to be a weak one. So, oh, because you're going to have the list of strong acids or bases memorized. Okay. There's only like 6 of them. 6 or 7. So it's not a huge list, and the bases are really easy. I'll show you a trick for those in just a second. In AP Chem, but there's not that many even worldwide. Most of them are weak. All right. By the test that you're taking November 30th, yes. Yes, you need to have them memorized by then. Again, the bases will memorize very, very easily. You're not going to have um, any any issues trying to do that. Okay. So it's important to know that the stronger acid will form the weaker conjugate base. And this is hard for me to remember. So you guys need to figure out a way to get this in your brain because I have a hard time doing this. I don't have stronger acid. So if it's a strong acid over here, stronger. And at this point, they're going to have to tell you that because you're not going to have information to give you that. Okay. Eventually, when we get to unit 8, you will have that quantitative data and be able to determine that yourself. But right now, you just need to read the problem, and it'll say stronger acid. Okay. And then that means that you've got the weaker acid over here. Okay. And you're also going to have the weaker conjugate base on this side, which means that you're going to have the stronger base on this side. So strong, strong, weaker, weaker. So whichever side's the strong acid's also going to be the strong base. Whichever side's the weak acid's going to be the weaker base. An acid-base reaction will favor the formation of the weaker acid and base. The conjugate of the strong acid or strong base has no acidic or basic properties. Good? All right. All right. So this is what you need to memorize. Okay. 1, 2, 3, 4, 5, 6, 7 here. And then looks like 7 on this side. Okay. So these you've just got to memorize. Okay. So you've got chloric acid, you've got hydrobromic. So this ends up being a halogen, a halogen, a halogen. Right? This is a form with that halogen. And then you've got to just figure nitric, and the first hydrogen off of the sulfuric is strong. The second one is not. What do I mean by that? What happens is you've got H2SO4, and if you have water present, what's going to happen is that's going to form HSO4 minus plus H3O plus. This right here is a strong acid. If you then take this guy, because he's still an acid, and he's still in that water, some of it will ionize and some of it won't. And you'll end up with this as one of the products. That should be 2 minus. Okay, this is a weak acid. And you can tell that because it's not on this list, and I drew this arrow in this format. Okay. Now, as far as memorizing these guys go, what you have to do is you have to look at all of these right here. They're all in the same position that they would be on a periodic table. And then if you kick over one, you get calcium, strontium, and barium. So if you look at these positioned on the periodic table, that's how they're positioned. And so that makes this an easy thing to kind of memorize, because you just take these guys, put it on the periodic table, kick over, and then you've got these. Does that make sense? And then you just add hydroxides on the end of them. So these are easy to memorize, I think, personally, because you just use the periodic table to help you out on that one. Okay. These, however, are going to require a little bit of work. But really, do you really have to memorize a lot here? No. So then all you've got is 7 of these. And I mean, 3 of them look dramatically similar to one another. The other 2 are, these 3 right here are all halogens. So it's not too much of a stretch to get these memorized, I don't think. All right. Questions? So memorize them. All right. Identify which of the reactions is an acid-base reaction. Then identify the acid-base, conjugate acid, and conjugate base in the reaction. And it looks like here I didn't do a stellar job of getting this enlarged, so sorry about that. All right, so my copper here, its oxidation number is 0. My aluminum is a +3. Here my aluminum is 0, and here my copper is a +2. Yep, oxidation number is the charge. So what type of reaction is this? Redox. Redox. This is a redox reaction. So this is not the acid-base one that they're talking about. Here we have our hydrogen and our oxygen going over here to form this guy. Are we forming an acid and a base over here? No. So this is not, this is a synthesis, or what do they call it? Composition reaction, I think I don't know. I call it a synthesis. All right, here, okay, this is our acid base one. Yep. So here, our hydrogen here, we've added another one here. So this is my acid. This is my base. This was a conjugate acid because it's on this side. Here, this is my acid. I don't know why that came up. And this is my conjugate base. Okay. Now, what is wrong? There is something still wrong with this reaction the way they have it written. Right, the arrow. This arrow should be drawn like, oops. Oh, I guess I can recover that way. Like that. Because this is a weak base. Yep, this is a weak base. Yep. Yeah. All right, down here, is this an acid-base reaction? No, this is simply a synthesis reaction. Okay. All right, you do. So identify the two conjugate base pairs in the reaction shown above. So what are the acid and base pairs? And then if this guy is the stronger base, okay, which is the stronger acid? Okay, make sense? Does that work for you guys? Now, Matthew, you wanted me to answer some questions about acids and bases today. Have I answered those questions, or so you're feeling good about it now? Okay. Anybody else have any other questions? Okay.
So the stronger acid and stronger base are always on the same side?